A production application is humming along until suddenly requests start timing out. Within minutes, the application crashes and the servers lock up entirely. The processor isn't overloaded and the network is stable. The operating system simply ran out of disk space. Out of the box, AWS CloudWatch tracks the exterior hardware of your EC2 instances. It records CPU usage, network traffic, and disk read and write operations. But that data bounces right off the guest operating system. By default, AWS does not track internal OS metrics like remaining disk space or memory utilization. To gain visibility, we have to bridge that gap. We do this by installing the CloudWatch agent directly on the guest operating system. This agent gathers internal metrics and transmits them back to AWS, allowing us to build an automated alert system for our disks. To execute this setup, you need an active AWS account, a running Linux EC2 instance, and SSH terminal access to that instance. Setting up OS-level instrumentation is a requirement for system stability. Without it, you are blind to internal resource consumption that eventually leads to service failure. We begin by establishing an SSH connection to the guest OS. Open your terminal and log in using your private key and the instance's public IP address. Once inside the Linux environment, use the command line to download and install the CloudWatch agent package. After the installation, we run the configuration wizard to specify that we want to track disk space metrics. Start the agent service. The terminal will provide a status string confirming the agent is initialized and actively transmitting data. With the agent running, we return to the AWS Management Console to locate the new metrics. Navigate to the CloudWatch service. Locate your custom Linux namespace. Select the disk utilization metric and choose to create an alarm. Define the alarm parameters to trigger whenever disk utilization reaches exactly 85%. This threshold gives you a lead time to resolve the issue before the drive hits total capacity. These customized metrics move your operations from a reactive state to a predictable one, where you are alerted to storage shortages automatically. Imagine the 85% capacity alarm has just triggered. We have to decide immediately how to clear the bottleneck. There are two strategies: manual cleanup by deleting OS files or expanding the EBS volume. For manual triage, use DF to check partition status and DU to isolate the specific directories consuming the most space. Before you delete anything, run the lsof command. This scans the system for hidden open files that are still being accessed by background processes. If you delete a file while a process is still writing to it, the file reference disappears from the directory, but the Linux kernel does not release the storage blocks. This results in a ghost file where the disk remains full, even though the file appears to be gone. Because manual cleanup relies on constant OS-level troubleshooting and carries the risk of locked files, it is usually a temporary fix for a system that simply needs more capacity. When the drive is filled with essential data that cannot be deleted, the definitive solution is to resize the active EBS volume. First, modify your volume in the AWS console to increase its size. Wait for the AWS backend optimization to finish adjusting the underlying storage blocks. Finally, run resize2fs in the Linux terminal to extend the file system into the new capacity. If you skip the file system extension, the new EBS space will be completely invisible to Linux. The OS will continue to report a full disk until it is told the boundaries have moved. Infrastructure changes at the AWS level always require a corresponding configuration at the operating system level to become functional. Now that we have extended the file system, we can verify that the crisis is resolved. A final check of the df-h command shows the new, larger capacity is available to Linux. Simultaneously, the CloudWatch alarm status should transition back to OK as utilization drops. You have successfully configured OS-level monitoring and mastered the workflow for permanent storage expansion. Managing the intersection between AWS infrastructure and the guest OS ensures you can resolve storage bottlenecks without data loss. This same visibility allows you to set up automated snapshots to protect your newly expanded volumes.